Okay, so 11.1. So I think there's 4 different graphs we're going to go over. First one we're looking at is called a dot plot. And this is a statistical graph. That shows the shape of a data set with stacked dots above a number line. A statistical graph that shows the shape of a data set with stacked dots above a number line. So our example, Manuel plans to buy a new car, the gas mileage 26 miles per gallon. To determine if the gas mileage of the car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. Okay. So we want to create a dot plot to represent this data. So what we want to start off with is figuring out what's the minimum. What's the smallest number? 25. Okay. And what about our maximum? What's our largest number? Higher? 45. 45. So what we're going to do is we're going to make a number line. And we're going to go from 25 to 45. So remember what I talked about the other day when we were graphing scatter plots? I'm okay if you don't write every number. So we can go 25 and then do 4 small lines, 1 big line to represent 30, 4 small, 1 big for 35, 4 small, 1 big to represent 40, 4 small, 1 big, 45. And then to make our dot plot, we're literally going to place a dot above the number line for each number. So 25, I'm going to put a point above 25. Next number, 45, put a dot above 45. Next number, 26, put a dot above 26. 35, put a dot above 35. Put a dot above 31. Okay, 26. We already have 26. So what we're going to do is we're going to stack it. So we're going to put another one on top of the one that's already there. 30. 28. 29. Another one on 26. Another one on 28. Another one on 26. 27. A second one on 27. And then 2 more on 28. And then the one thing that our dot plot is missing is a label of some sort. What do each of these numbers represent? What was it? Gas mileage, or how about miles per gallon? Miles per gallon. Okay. Do not forget to label. And on your test, if we ask you to make a dot plot, if you're missing your label, you're going to miss a point. Okay. But that's all a dot plot is. Plot points above a number line. Are we okay with that?
Yep.
Okay. So now let's answer some questions. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of other cars he researched? So he said he wanted to buy a car with gas mileage of 26 miles per gallon. Is that completely off base of the dot plot? Is that similar?
That one has one of the most.
That one has one of the most. Okay, so this part's going to be different for each of you. Okay, like if this was asked on your test. But we can say 26 miles per gallon. I'm going to abbreviate MPG. Is about the same. Fuel efficiency. Of the researched cars. How about E? Okay. And then we have a little bit of vocab we're going to throw in here. Okay. Nice thing about dot plots is it's really easy to see some key characteristics about that. Okay. So the first one we're going to talk about is an outlier. Okay. Is there a data point that falls outside of the rest of the data? It lies outside.
45 and 35.
So it's actually just going to be 45 because it's really far away. Okay, so the definition of an outlier is a data value not near the rest of the data set. And we're going to talk tomorrow about how an outlier affects data. Okay, the next vocab we're going to look at is a cluster. I'm going to give you the definition first. So a cluster is where the majority of data lies or falls.
You would name multiple numbers.
Not necessarily multiple numbers. So like we have a cluster over here on the far left. So this is a cluster of data. It's all in one general spot. 25 to 31. 25 to 31. Okay. And then the last one we're going to talk about is a gap. Okay, I'm going to leave a space again. And a gap is space where no data falls. Okay. So if you have an outlier, you're going to have a gap. Here we actually have two gaps. Where are our gaps at? Between what two data entries? How about from 31 to 35? And then from 35 to 45. That would be considered your gap. Okay. Questions about dot plots? All right. Next one is probably one of the most frequently used in statistics. And I'll say they probably require like the most amount of work to make, but they're easiest to find information from. Okay. So a histogram, and write kind of small or start at the top. Okay, is a statistical graph that shows the shape of a data set with vertical bars above intervals on a number line. So the thing that's going to be different on this is instead of writing every number, we're going to have kind of gaps between them. It's similar to a bar graph, except, let's see here. I'm going to add a couple things in. We're going to have equal intervals. With no overlap. Causing bars to touch, which is what makes a histogram slightly different than a bar graph. Normally when you make a bar graph, there's going to be some spaces in between. Here we're not going to have any spaces. And then the height of the bar shows the frequency. The height of the bar shows the frequency. Okay. All right, so our example. A marketing team is about to launch a campaign for a new product that is targeted at adults aged 25 to 34 years old. The team is researching the age range of viewers of a certain, that's definitely spelled wrong, sorry. Pretend that says viewers, of a certain TV show, decide whether to advertise during that show. The data shows the ages of a random sample of 30 viewers of the show. So we are going to create a frequency table to organize the data with intervals of size 5, beginning at 0, and then create a histogram to represent that data. Okay, so over on this far left, we're going to create a table. And we're going to have age range. And then we're going to look for the frequency. So frequency means like how many times does that occur? Okay. It tells us in the problem to start at age 0. So our first age range is going to go from 0. And then it says a size of what? 5. Here's where you have to be careful. Count your numbers. So if we start at 0, that's our first number. And then we would go to 1, 2, 3, 4. That has 5 numbers in it, right? So this age range 0 to 4, not 0 to 5, because you actually have to count those numbers out. So your next one, because we aren't going to have any overlaps, is going to start at 5. All right. 5, 6, 7, 8, 9. So it's going to go from 5 to 9. Okay. Here's where that interval size falls. From here to here, and from here to here. That is your interval. So if you want to add, you're going to add from the beginning of each one or the end of each one, not in between the two classes. Okay. Okay, so if we wanted to continue this, so after 9 comes 10, 10 to 14, and then we're going to have
15 to 19.
15 to 19. And what do we need to go up to? What's our largest number in this data set?
37.
37. So we need to make sure we go past 37. So we're going to have 20 to 24, 25 to 29, 30 to 34, and 35 to 39. Okay. Questions with that part? That's probably the hardest part about making this. Okay, is creating that frequency table. Okay, so now you're going to go through and make tally marks. Okay, so 14. That falls between 10 and 14. We're going to go and put a tally there. Okay, and then I recommend cross it off in your table. So that way you don't repeat something. All right, then going to the right, we have 21. That falls between 20 and 24. 22 falls between 20 and 24. And I want you to finish your table. Go through and make your tallies. Okay, once you've finished your tallies, count up how many there are. So from 0 to 4, we don't have any, so I'm just going to leave it blank. 5 to 9, we don't have any. How many from 10 to 14? 2. 15 to 19?
10,
10. 20 to 24?
10,
25 to 29?
4,
4. 30 to 34?
3,
And 35 to 39?
1.
1. Here's what I recommend you do. Add those up. So let's do, what's 10 plus 10? Plus 2? Plus 4? Plus 3?
29,
Plus 1?
30,
Okay. We add those all up, we get 30. Does that match the sample size we were given? How many data numbers?
30.
Yes. If it doesn't match, you missed a number. Okay. So let's see here. Let me put it out there. Matches sample. Okay. If it doesn't match the sample, you miss something. Questions with making a frequency table? All right. Now let's make our histogram. Okay, so we're going to make an XY axis. Okay. But here's the thing, when you make your x-axis, make sure you leave like a space underneath it. So we can label that axis. Okay. Make sure you leave some space to write. All right, let's start with our y-axis. That's the easiest. So our frequency, what was our largest frequency?
37.
Careful, largest frequency? That's over here.
39.
That's over here. 10. So we're going to need to go up to 10. So I'm going to go by 2s, but make a dash for every one. And we're going to label this frequency. Okay. And then I'm going to put a 0 here on the bottom. We need to write out each of those intervals we just found for our age ranges. So we're going to start off, we have 0 to 4, and then leave a little bit of a space. We're going to write 5 to 9, 10 to 14, 15 to 19. I'm afraid I might run out of room. Let's see here. This keeps moving. All right, we got 20 to 24, 25 to 29, 30 to 34, and 35 to 39. Okay, and those represented age. Okay. And this is easier if you're doing it on line paper, I promise. Okay. Mm-hmm. Okay. And then you're going to make a bar graph connecting your bars. So from 10 to 14, we had a frequency of 2. So I'm going to make a bar that goes up to 2. 15 and 19 goes up to 10. So that bar is going to be touching. Okay. And then goes across. 20 to 24 is 10. 25 to 29, 4. 30 to 34, 3. And 35 to 39, 1. So the thing about a histogram is your data is all grouped together. Okay. One thing that's nice about a dot plot is it's all individual. But here when we look at this graph, it's grouped. But now it's also easier sometimes to answer the question it's asking. Based on the findings, should the marketing team launch their campaign during this particular show? What was their target range in the example? Okay, so the target was ages 25 to 34. Well, based on either your frequency table or your histogram, how many did that include? 7. So 7 people. So is that a good idea?
No.
No. So we can say no, because this only accounts for 7 out of how many people? Out of the 30 viewers. Okay. One thing you're going to see in your homework is finding a percentage. Okay, so if you take 7 divided by 30 and you change that, multiply it by 100 to make it into a percent, it's going to be about 23% of the viewers. which is obviously a very small amount. Okay,
Is that 23%?
23. So what age group would be a good match for products in this show? 15 through 24. Years old. Because, okay, well, how many are between 15 and 24 years old? 20. 20 divided by 30? Going to give us 67% of the viewers sampled. Okay. And the key thing about histograms, like I said earlier, this is going to give us grouped data, not individual data. Okay, because here's what that means. If you were just given this frequency, I'm going to zoom this in real quick. If you were just given this picture, this graph, could you tell me how many were age 16? No. You could say that between age 15 and 19, there's 10 of them, but they could all be 15 years old. They could all be 19 years old. You don't know specifics. Okay, so that's the one problem with histogram. Okay, does that make sense? All right,